In the late 1600s, Sir Isaac Newton observed the effects of gravity. An apple falling from the tree, as the story goes, and he used these effects to come up with his universal law of gravitation. Now, what we have here is Newton's universal law of gravitation. What it consists of? Two masses, m1 and m2. They're over distance squared. They equal F, which stands for the force of attraction. Much like duct tape, this holds the universe together. Now, the fifth component of this equation is G, the gravitational constant. This balances the scales and gives us our universal law of gravitation. Now, what we're doing today is we're going to find G in the universal law of gravitation. And to assist us in that, we have this little apparatus here. Basically, it's a timer. We have a sensor here and a switch there. When an object falls past the sensor, the timer on the computer starts. When an object hits this switch, the timer on the computer stops. Now, we have our little fishball here. Its name is Nemo. We're going to drop Nemo past the sensor. Okay, that was a successful run. And according to the computer, that was 421 milliseconds. Now, the first thing we're going to do, first step we're going to take to find G, is to find the acceleration due to gravity on Earth. Now, we ran Nemo through our mechanism 6 times. And we did some calculations involving Newton's second law and Newton's law of universal gravitation. The value we got for G was 9.9 times 10 to the negative 11. The real value of G is 6.7 times 10 to the negative 11. That means that we were only a few hundredth of a billionth off of the real value of G. What that also proves, with that closeness, is that Newton's universal law of gravitation is an incredibly accurate way of describing the effects of gravity. So there you have it. We have gravity, and thanks to Newton and the universal law of gravitation, we know how to define it. Without gravity, you wouldn't be kept in your bed at night. Without gravity, the Earth would crash with the moon. Without gravity, we'd all be little teeny particles of dust floating around in no particular order. Without gravity, things would suck.